Ever get totally stumped by those acid concentration questions in your SPM chemistry paper? Yeah, you're not the only one. But don't worry, in this quick session, we're going to crack this tricky topic wide open and turn that confusion into some serious confidence. Let's do this!
Okay, but first, real quick, the best way to absolutely nail this stuff is to practice. You can find thousands of questions over at MCQSPM.com. Or, even better, just whip out your phone right now, scan this QR code, and get the app downloaded. You'll thank me later for sure.
All right, let's jump right into it. I want to show you a classic exam trap. This is the kind of question that looks super easy on the surface, but bam, it's designed to catch you out even if you've done all your revision.
So, you've probably seen something just like this, right? We've got two different acids, ethanoic and hydrochloric, and they have the exact same concentration. But then you look at their pH values, and they're totally different. How is that even possible? It feels like it breaks the rules. Well, that's the trap. It wants you to think beyond just that one number.
And here's the secret, the big reveal. It's got very little to do with how much acid you're pouring in. It's all about what the acid does once it actually hits the water. And the magic word, the one you absolutely need to remember, is ionization. Let's really unpack what that means.
Now, to make this whole idea of ionization super clear, let's use a little analogy. I want you to completely forget about beakers and chemicals for a second. Just picture this. You're in a pitch-black room, and you need to light it up.
So, a strong acid? That's like a giant, powerful floodlight. You flick the switch, and boom, it completely floods the room with bright light. It gives you everything it's got, all at once. Now, a weak acid, think of that more like a delicate string of fairy lights. You plug it in, and you get this gentle, pretty glow. See the difference? The key thing here is that both the floodlight and the fairy lights are plugged into the same power socket. That's our concentration. But the amount of light they actually produce, our H+ ion concentration, is worlds apart.
Okay, so let's translate that back to proper chemistry terms. A strong acid, our floodlight, is an acid that ionizes or breaks apart completely when you put it in water. I mean, every single molecule splits up and releases its hydrogen ions. This gives you a really high concentration of H+ ions, and that's why the pH is so low. And yep, hydrochloric acid is your classic example of this.
And on the flip side, we've got our weak acid, the fairy lights. This one only ionizes partially, so just a tiny little fraction of the molecules actually bother to break apart and release their hydrogen ions. The result? A much lower concentration of H+ ions, which means a higher pH value when you compare it to a strong acid with the same concentration. And that is exactly what's going on with our friend ethanoic acid from that first question.
Okay, theory's down. Now for the fun part. Let's put on our detective hats and crack the SPM code. See, the examiners, they're kind of predictable. They use the same patterns over and over again. Once you learn how to spot these patterns, you're golden. Let's check out the first one.
So here's a very common pattern, a question that asks you to compare two strong acids, like sulphuric acid and hydrochloric acid. Now wait a minute, aren't they both floodlights? So why would there be any difference? The question itself is giving you a huge clue. It's pointing you to look at another property.
The key word you need to have locked in your brain for this is diprotic. Okay, so hydrochloric acid is what we call monoprotic. Mono means one, so it gives off one hydrogen ion. But sulphuric acid, just look at the formula, H2SO4. It's diprotic. Di means two. Each molecule gives up two hydrogen ions. It's like our floodlight has two super powerful bulbs instead of just one.
And here's why that's a total game changer. Let's say you have a 0.1 molar solution of sulphuric acid. Because each molecule gives off two H+ ions, you actually end up with a 0.2 molar concentration of hydrogen ions. That's literally double what you'd get from hydrochloric acid at the same concentration. And that, my friends, is the trick. Now you know exactly what to look for.
All right, pattern number 2, and I can pretty much guarantee you'll see this one, the dilution calculation. It looks scary, I know, with all the numbers, but it's really not. They just give you a strong, concentrated acid and ask you how much of it you need to make a weaker, more diluted version. Seriously, don't sweat these. There's one simple formula that's going to be your new best friend. M1V1 equals M2V2. That's it. M1 and V1, that's for your starting, strong stuff. M2 and V2 are for the final, diluted stuff you want to make. All you have to do is plug in the numbers they give you. In this case, M1 is 2, M2 is 0.5, and V2 is 200. The only thing we don't know is V1, so that's what we solve for. Easy.
You do the quick math, and what do you get?
Boom, 50 cubic centimeters. See, it's that straightforward once you have the formula. Just lock that formula in your head, do a few practice runs, and those marks are yours every single time.
Whew, okay. We've covered a ton of ground, from the big ideas all the way to those sneaky exam tricks. So let's wrap this all up. Let's condense it down into one final, super powerful checklist you can use for your revision. Okay, here it is, your cheat sheet. Number 1, strength and concentration are not the same thing. Strength is all about ionization. Number 2, remember our analogy. Strong acids are floodlights, weak acids are fairy lights. Number 3, keep an eye out for that keyword diprotic, especially for acids like sulphuric acid. And finally, number 4, your absolute best friend for calculations, M1V1 equals M2V2. Got it?
And that's a wrap. You are now officially armed with the concepts and the strategies to absolutely smash these questions. So, I'm going to leave you with a challenge. You know the patterns from the past, so what do you think the trick question is going to be on this year's exam? What's the new twist they'll come up with? Start thinking like an examiner, and I promise you will never, ever be caught off guard. All the best!